do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. Find us on the web at gotime.fm, on the Fediverse at GoTime, at changelog.social, and on X at GoTimeFM. Thanks to our partners at Fly.io, the home of changelog.com. Launch your app as close to your users as possible. Find out how at Fly.io. Okay, here we go.
Our friends at Fire Hydrant offer modern engineering teams less stress from ring to retro, full end-to-end incident management, alerting, on-call, and of course, streamlining every aspect of your incident process. From webhook to alert trigger to notifications to incidents open to retro tasks to mean time to X analytics, everything is inside Fire Hydrant for modern engineering teams. And what you're about to hear are real reactions from PagerDuty users when seeing signals from Fire Hydrant for the first time.
PagerDuty, I don't want to say they're evil, but they're an evil that we've had to maintain. I know all of our engineering teams, as well as myself, are interested in getting this moving the correct direction. As right now, just managing and maintaining our user seats has become problematic.
That's really good. Actually, this is a consistent problem for us and teams. Is that covering these sorts of ad hoc time frames is very difficult. Putting in like overrides and specific days and different new shifts is quite onerous.
Well, and you did the most important piece, which is didn't tie them together, because that's half the problem with PagerDuty, right? Is I get all these alerts and then I get an incident per alert. And generally speaking, when it goes sideways, you get lots of alerts because lots of things are broken, but you only have one incident.
Yeah, I'm super impressed with that because being able to assign to different teams is an issue for us because like the one alert fires for one team and then it seems like to have to bounce around and it never does, which then means that we have tons of communication issues because like people aren't updated.
No, I mean, to be open and honest, when can we switch?
Okay, the next step is to go to firehydrant.com/signals, assemble the team, and work the problem without a single swivel of the chair. Fire Hydrant delivers end-to-end incident management and on-call alerting for the modern software teams. Get started for free. Once again, firehydrant.com/signals.
My name is Natalie and I'm joined again by the three Musketeers, Roland, Nicola and Filippo. How are you doing?
Well,
we are fine, thanks.
What is your favorite fencing style, speaking of Musketeers? Can be instead of the unpopular opinion.
Yeah, the only thing I know about fencing is the term épée, because it's used in the crossword all the time, but I have no idea what it actually means.
So my answer is Kerma, but I don't actually know if that's an English. In English, we also use the same name or not.
Yeah, the one with swords. I think that's
There's three types of those. There's one where you can only stab in like specific parts of the body. There's ones where you can only get points if you attack, and one is all the rest. We can consider switching the unpopular opinion for that part. Fun trivia. I used to be a fencer all through high school. So I love talking about that. Plus it's all for one, 3 for 1 or something. Yeah. Third episode. So exciting things will come with Go 123.
Well, when you said part 3, in my head I thought, oh, maybe it's part 3 of 5, and then we'll be done, and we'll not need to make any changes anymore, right?
The security trilogy ends before. Yeah.
But yes, as Roland was saying earlier, work is never ending.
No.
Yeah, that's probably a good thing, though. It provides a level of job security that is reassuring.
Roland, we're not supposed to talk about this in public. Anyway, yes, Go 123, lots of nice stuff coming. There's a bunch of crypto TLS things coming from Roland. So, I'm
getting you started.
Yeah, we can start with that. Yes, crypto TLS. I think it's probably one of the most used packages that we have in the crypto subtree. Whether people kind of know that they're using it or not. If you're using a net HTTP client, you probably use crypto TLS without ever knowing, which is nice. There hasn't been many major protocol changes for a while. The big thing that is coming down the road now is what's referred to as encrypted client hello, which is not a particularly great name if you have no idea about the semantics of TLS handshaking. And used to be called, there was a precursor effort that was called encrypted SNI, encrypted server name indication, which is when you do a TLS connection, because in most modern web servers now you have a single server serving a lot of different websites. You could have, there's a little field that happens during the TLS handshake that says which server you're actually trying to connect to. You're connecting to 1.1.1.1, but actually you want to connect to, dns.cloudflare.com. Or I forget what the host name they actually use is, but so you provide that little piece of information that lets the TLS stack know this is who I'm actually trying to talk to. But privacy people quite rightly brought up the fact that this kind of leaks in plain text who it is that you're trying to talk to. So, the network stack has slowly been trying to get rid of these privacy blind spots. And we now have secure DNS. So someone who is just watching your network traffic cannot see that you're looking up the IP address for cloudflare.com. But as soon as you do a TLS handshake, you're leaking this information, saying, actually, hey, this is exactly who I'm looking for. So the idea was to change TLS to allow you to kind of mask this information. So this is what is now called encrypted client hello, which I won't get into the details of the actual protocol changes because it's not particularly interesting and it's very complicated. But I think this is a really nice change that will, for most people, be completely transparent. I think the idea is that once we have support for it in Go, we will be able to wire up the net HTTP clients and everything that relies on that. So that assuming that you are using secure DNS, which is another problem that while there is a solution for it, who knows how many people are actually using it, there will be we're slowly reducing the kind of privacy leakage that happens when you try and connect to servers, which is nice. And for 99% of users, they will get this win transparently. You won't have to do anything. There will be some, people doing strange things with TLS will probably need to make some changes, but they are thankfully in the minority of people.
Yep. There's also an interesting API angle there because ECH uses a different specification called, I pronounce it wrong every time, HPKE.
Yeah,
yes?
Hybrid public key encryption.
Yes.
And ECH is?
Encrypted client hello. HPKE is something that will probably end up wanting to, maybe I'm not committing to anything, exposed in the standard library. And so Roland's first iteration is a useful starting point to figure out what the API should be. Because HPKE is one of those things where you can combine everything with everything else. And we hate exposing those in the standard library. So we'll have to figure it out.
Typically we try, this may sound kind of mean, but typically we try to give people as little options as possible. Turns out that making things highly configurable is often what leads to extremely painful bugs. So, we try and provide APIs that are very easy to use and don't require a huge amount of thought. Problem with HPKE is that it provides you a huge amount of options. And how to use it is complicated. So we are lucky that we are able to kind of land a first try implementation, get some experience in actually using it inside the standard library ourselves, and then see, how could you use this incorrectly? and then slowly file away those edges before we publicly propose an API that everyone else will have to use. Because once we land something in the standard library, it's kind of set in stone. So we really want to try and get it right the first time as much as possible.
The other thing that's coming to crypto-TLS in 123 is post-quantum connections. Did we talk about post-quantum last time? I don't remember.
I think we talked about it in the first episode 6 months ago.
Yes. So, yes,
alongside HPKE and the elliptical curves.
Right. So I'll keep relatively short what post-quantum is. It's just maybe quantum computers are coming, maybe not. The maybe yes is a little too big to ignore it, and if they come, they will be able to decrypt everything retroactively, and we kind of don't like that. So symmetric encryption is fine. So the ciphers are fine. AES is fine. Cha-Cha-20, Poly 1305 is fine. The thing we need to do something about are the key exchanges, which right now is P250 elliptic curve Diffie-Hellman, so P256 or curve 25519 and so on. So there are these new things, these new algorithms. They're called chems. What happened since the 6 months ago is that NIST put out drafts for how the specification of the one they selected should work, and we landed an internal implementation yesterday, I think.
Something like that, yeah.
Nice.
Yep.
2 days ago, maybe.
2 days ago.
And yesterday there was, you sent a performance optimization, if I remember correctly.
Yeah, because I figured there should always be a CL waiting for Roland's review, just to keep him on his toes. And yeah, so we have an implementation in the standard library. I went specifically only for 768, which is one of the parameter sizes, which I'm hoping everybody will just use that, and I'm hoping we'll get away with only supporting that for as long as possible, which is probably like a year or two. But anyway, we're not exposing that in the standard library in 123. The plan is to wire it into crypto-TLS, so that if you connect to another TLS peer that also supports these post-quantum hybrids, by the way, that use both the new stuff and the old stuff, so that, if we get the new stuff wrong, it's not worse than using the old stuff. And this is a whole debate, by the way, which we're going to elide here. And we're going to use to implement this. And it does make handshakes a little chunkier, a little bigger, which hopefully is not too much of a problem. Hopefully it's something that we can just turn on, people don't notice, and suddenly their connections are sometimes post-quantum secure. But yeah, we're rolling it out just as an experiment initially, just like HPKE, then thinking about what the right API to expose it is going to be.
Are you collecting some metrics or feedbacks about that?
Metrics? That would be great. It would be great to have those, but we don't get to have those. So
you're looking for feedback.
Yes. It works like we put things in the release candidate and we tell people to test the release candidate, and nobody tries the release candidate, and then we make the release because we say, great, we did not break anybody. And then the release comes and everybody comes out and says that we broke them.
So you're asking now security people, anybody who has like extra focus on security in their tools, to try the release candidate for 23?
No, that's the thing. It's not about security focus. I don't need anybody to if they also want to review the security of it, great. But no, we just need people who used crypto-TLS, which, like Roland was saying, is everybody, to try the release candidate.
Anybody who uses net HTTP to try the release candidate.
Yes. Everybody should always try the release candidate, because we are so happy when you show up with bugs during the release candidate period, and so not as happy when you show up with bugs like a month after the release. And not every bug can be found in Canary, but consider that the release candidate is what Google uses internally for production. So you can stick it on a lab machine or to check if, it still connects to your old firewall that's been living in a closet with no power, and nobody really knows how it's still running, and everybody's afraid to ask, but somehow that one rejects handshakes with the new post-quantum stuff, and we would like to know before.
A large part of testing for this will really just be interoperability with other implementations of MLChem. I think, Chrome has landed an implementation. I think Firefox has an implementation. OpenSSL almost definitely has an implementation. So it's more just figuring out, is there some corner case between the Go implementation and one of the multitude of other implementations out there that will cause something to explode spectacularly.
We will be using the Go debugs that I think we talked about in one of the episodes. So whether we turn it on by default or not will depend on the Go line in your Go mod, which is something I feel like we should communicate much better, because you can install the release candidate, but you will still not be testing the thing unless you change the Go mod line. But on the other hand, to test the release candidate, it's as easy as writing Go 1.23rc1 in your Go mod file, and Go will automatically go fetch the new thing from the module's proxy and will automatically run the new version. We really should write more about how all of that works, because I see Roland being like, is that how it works?
Well, I was going to say, there is I think Russ Cox wrote a whole long blog post about this. I was trying to figure out, can you put RC1 in your...
Yes.
Oh, okay, interesting. I didn't know that.
It's the thing you can do. You can just change that line in the Go mod, kick off CI, and in theory it should just run the RC.
Yeah, I mean, this probably also tells you about how much I write actual Go modules rather than my day is spent in the standard library in such a way that I'm slightly ignorant of how a lot of the toolchain works for normal people.
What's up, friends and party people? I'm here with my good friend over at Speakeasy, founding engineer George Hadar. Speakeasy is the complete platform for great API developer experience. They help you produce SDKs, Terraform providers, docs, and more. George, take me on a journey through this process. Help me understand exactly what it takes to generate an SDK for an API at the quality level required for good user experience, good dev experience.
The reality is, the larger your API becomes, the more you want to support users that want to use your API. And to do that, your instinct will be to ship a library, a package, and what we've been calling an SDK. There's a lot of effort involved in taking an API that lives in the world and creating a piece of software that can talk to that API. Building SDKs by hand is a significant investment, and a lot of large companies might pour a lot of money into that effort to create something that's like approaches good developer experience. And then another group of, a more growing group of companies will rely on tooling like code generators. And so they're very interested in, like, once you make the decision to use a code generator, you're kind of forfeiting some of your own opinions and what you think a good developer experience is, because you're going to delegate that to a code generator to give you an SDK that you think users will enjoy using.
So there's various open source tooling out there that can do a version of what you do. How much research have you all put into doing it at a quality level that is enterprise API ready?
A lot of the customers that we've spoken to didn't have that experience. So they went to code generators, they tried to point them at their APIs and tell them, give me an SDK, and the outcome wasn't great. Like, it didn't support some of the features in OpenAPI, or the code that it was generating was not idiomatic TypeScript. We didn't boldly think we're gonna solve this better than everyone else. The reality is that that's where we came in. We surveyed all the things that have happened in JavaScript over the last few years, all the incredible projects like Zod, for example, and the web platform APIs that are now like broadly supported, like the Fetch API, the Web Streams API. We kind of saw this and said, there's a great opportunity to mix all these together and create the best experience you can get out of a code generator for users.
Okay, so paint a picture. What's a good next step? What can people expect when they go to speakeasyapi.dev?
If you're coming across Speakeasy today and you want to use it, you will go through the onboarding flow, and at some point you're going to give us an OpenAPI document. That's your description of your API, and we're going to take that document and turn it into an SDK of your choice. You're going to get to pick which language is your first language. That's the one you'll get for free. And at that point, you can publish that package for the world to use. That's going to be yours. It's you get to license that however you want, and then carry on from there. The way you iterate now is you keep changing your Open API document. So as you develop your backend, you're going to produce alongside that the Open API document with any updates over time and evolve that. And as you're evolving that, we're generating the SDKs and publishing them for you. And that also includes rich documentation that goes with them. So we're asking you to put a lot of effort just into describing your API, and we're going to do a lot of the heavy lifting that follows from that.
Okay, so as George mentioned, go to speakeasyapi.dev. You get your first SDK for free. So cool. Once again, speakeasyapi.dev.
Is that also a plan? Speaking of MLChem, is there a have the SSH people specified using MLChem in OpenSSH? Is that something we have thought about?
I think this will be added later. Currently, I know about AWS in its AWS transfer family for SFTP already supporting post-quantum algorithm, but OpenSSH still does not ship this support. And we spoken about this with Filippo some time ago, and we'll try to support post-quantum algorithm, post-quantum key exchange after OpenSSH ship with the release or ship to their GitHub today Git repository for the portable OpenSSH. And it's also, since these new crypto algorithms are internal to Go, it's also very important to move crypto SSH from Xcrypto to Go itself, so it can use the internal import to use this new algorithm. It will be an interesting development, and also for SSH, it would be interesting to check the interoperability with other implementation, mainly OpenSSH, the leading implementation, but also AWS and other implementation that will add post-quantum support in the meantime.
Yep. By the way, OpenSSH, I think, has a different algorithm that's post-quantum because they picked it way before NIST made their choice. And they did not pick what NIST ended up picking. So we're not implementing, the other one and then Kyber or MLChem, which is just, the boring name for Kyber because we can't have nice things. So NIST renamed it.
Yeah. Did they pick one of the lattice-based ones or?
Yeah, Kyber being the lattice-based. OpenSSH. Yeah, OpenSSH had NTRU.
Okay.
Which is another one of the lattice-based ones. So really, there's no good reason to use one over the other. It's just a historical...
Yeah, they just got there first.
And regrettably,
I think it's already there since 2 years. It's a long time. It's not recent as addition.
And has anyone other than OpenSSH implemented this key exchange? Or?
I'm not aware of any other implementation, but
That's not shocking, but
indeed. But Nicola mentioned something about Xcrypto and crypto, which is a thing that we have 2 proposals out to get to, and maybe we'll start doing some of that in 123, maybe not. But my proposal is about deprecating a bunch of packages because I still like to go around with my deprecation hammer. I'm not done yet. And there's a few things left in Xcrypto that I did not get last time around, and I am getting this time around. And after that cleanup, it's partially aimed to making your proposal possible, Roland.
Yeah, so the other big proposal that we have is there's kind of this long history of the golang.org/x/crypto module, which everyone seems extremely confused about what the purpose is. It kind of exists as a historical artifact of people on the team at the time just needing a place to put code that they were working on. And over time, it has slowly morphed into a selection of incredibly important packages that the standard library relies on, and then a handful of things of, let's say, dubious quality that we have slowly been trying to deprecate or freeze or kind of pretend like do not exist for the last couple of years. So we've proposed that we will, to try and make this a slightly less confusing module, we will just move all of the code in golang.org/x/crypto that is important into the standard library. So you will no longer need to make the determination of, should I be using this thing from this /x repository? Does /x mean experimental? No, it doesn't. But it also, what it does mean is not particularly clear. So there are things in xcrypto like xcrypto SSH and xcrypto OCSP and xcrypto CryptoByte that are all things that we kind of rely on heavily in the standard library. And because of that, there seems like there is no good reason not to have them there. So the idea is that we will slowly start to move packages out of xcrypto SSH or xcrypto into the standard library. We will leave those packages in xcrypto, but they will eventually just become wrappers around the packages that exist in the standard library. So this won't break anyone who is still relying on, those APIs never changing or that code never moving, but they will just transparently start using actually the standard library without knowing it. And we'll get all of the benefits of that.
But at the same time, we have also, for example, for crypto SSH to refactor several things. So the wrapper will be not one-to-one, exactly one-to-one, but because we need to improve some things before joining with the standard library. And this is the reason this will not happen for one immediately, but for the next Go release, if all goes well.
Yeah. And we plan to do this as in kind of a piecemeal process. It will not necessarily all happen in a single release. There are some things that we can just kind of copy and paste. Their APIs are solid. We kind of don't necessarily need to make any changes. But like Nicola said, there are things that, had a hard life in xcrypto and, have developed the way they have. And kind of when we move them into the standard library, we're kind of getting a second chance to think like, is there a better way that we can design this API? Which I think for many things there are.
We can learn from the experience and from all the bug reports we receive, and so we'll do something better we'll try to do something better for the community. Always will be something unhappy from the change, but this is inevitable. We will try our best.
Yeah, and one of the great things about Go modules is that if people are really upset about something that we do, they can just use an older version of the module. Unless it turns out there is some massive security vulnerability, in which case they may be on their own. But I try to push that thought to the back of my mind.
Yeah, we can remove old stuff like old hash functions that.
Sounds like an internal joke is coming.
No, this is me teasing Roland about the fact that we've been. I'm actually teasing both of them simultaneously because Roland has been working on getting SHA-1 out of Crypto X509, which is the certificates verification library, and Nicola has been working on getting SHA-1 out of xcrypto SSH, and they have both been extremely painful.
Yeah, I think when was SHA-1 signatures in X509 certificates have been quote unquote banned in public certificates, i.e. certificates trusted by browsers for must be 5 years now, something like that. It's been quite a long time. People kind of saw the downfall of SHA-1 coming and started trying to replace them with more modern variants. But it turns out that, and when it was kind of announced that this would happen and most certificate authorities had transitioned to using SHA-256 based signatures, we decided, we can just get rid of SHA-1 signatures. We can just remove support in the Go X509 library for this. It will cause no problems, I'm sure, which we did, and then immediately got a lot of people shouting at us because it turns out that people rely on a lot of private public key infrastructure like enterprise certificates still use SHA-1, or they were connecting to people using point of sale terminals that had been designed in the 1990s and hadn't been updated since, that were relying on SHA-1 signatures and stuff like that. So we ended up adding a Go debug flag that let you opt in to SHA-1, still verifying SHA-1 signatures. 99% of people transparently just stopped needing to support them and had the support removed. And then we offered this flag that say, if you really need this, we will allow you to opt into retaining this behavior. And I think we added that flag about 3 years ago. And I believe at the time when we added it, we said, we will remove this in 1 or 2 major releases. I believe it's been about 6 major releases since we said that. We have finally got to the point where, as far as we can tell, there is no major either organization or software project still relying on this behavior. So the goal is that in 121, we won't make any code changes, but we will make an announcement that in 124, we are going to remove this flag, finally. And you will no longer, regardless of what you do, be able to verify SHA-1 signatures. That's technically not true. If you write a bunch of code, you can verify SHA-1 signatures yourself, but I'm not encouraging anyone to do that. If you need to do that, you need to go and think hard about what you're doing. And then in 124, we will just axe this support. And it will be the end of a very long journey.
Can you get ISO compliance using SHA-1, or do you have to show you're not using that?
It's possible.
So for FIPS, SHA-1 is not an approved algorithm anymore. It's allowed for legacy purposes when you're verifying existing signatures. So if you have like a thing that's already signed, you can use SHA-1 to verify it, which means it's not disallowed from being in a module. But if you still sign things with SHA-1, that is not okay.
No new signatures.
In SSH instead, we still have SHA-1 as default, enabled as default. There are also in SSH, there are very old devices relying on it. And one of the points to move crypto SSH within the standard library is to allow to disable SHA-1 using an environment variable. So we can make the same transition described by Roland. So in the first time, there will be an environment variable allowing to re-enable it. And then after some release, we'll remove this environment variable. Anytime after the recent development in crypto SSH, we now allow to completely disable SHA-1, but users need to configure themselves. In some pending work, we have exposed the supported algorithm, and we divided the algorithm in secure and in supported and insecure. If you have to explicitly enable insecure algorithm to have SHA-1. So if you import the supported algorithm, you will have SHA-1 and other unsecure algorithm disabled. We also worked to improve the things in other way. For example, we are working on exposing negotiated and supported algorithm. So our user can see what device need to be updated before disabling an algorithm, so they can plan the update. And we also simplified finding the algorithm by exposing an algorithm negotiation error. With the algorithm negotiation error, you will exactly know what algorithm negotiation failed, what are the supported algorithm, and what are the requested algorithm from the client or from the server. And this information before this change that we are still working on were available as a string within the error message. Now instead are more structured. The error will expose proper list that our user can search and match with the algorithm we exposed. So it will be much more easier to understand what device, what clients or server need to be updated and report the error to our users.
Yep. Also, I know that we just recently managed to fully round out support for the new hashes, because SSH used to say, oh, if you're using RSA, you must be using SHA-1. That's just completely tied. And, SSH is a protocol that has 20 years. We've learned a few things about how to do protocols since, and it's actually very impressive that it's still secure and still going well after 20 years. But one of the problems it had was that you had to use SHA-1 to use RSA. So then they split it and they said, okay, so you can use a key of type RSA, but that you can use with different algorithms. It can be with SHA-1 or with SHA-256 and so on. And that turned out so many bugs, because all over the place, things that were supposed to send the algorithm were sending the key type and mixing them up, or when a certificate was in use, hitting edge cases. We think we hit the last one today.
Yes, hopefully the last one. We will be merged in the next few days. And it was the last problem when a client needs to validate the server response for a public key. And it turned out the OpenSSH implementation, there was a shortcut in OpenSSH implementation. They don't validate the algorithm sent from the client with one received. So they just validate the key type. And it was a bug we had for a lot of time. There are at least 4 or 5 open issues about this. And because initially this bug was noticeable only with the proprietary server. Only recently, a user reported us a reproducer using a Node.js-based SSH implementation. So we can really understand what is going on, compare with OpenSSH code, which was working, of course, and apply the same workaround that violates the specification, of course. That's strange.
You gotta love the archaeology aspect of this, because what happened is that the spec was changed. Then OpenSSH implemented the spec correctly on one side, but on the other side, to make their job easier, they made it more lenient. But that just means that they supported more things. So far, so good, right? But since OpenSSH supported that, other implementations started making the mistake, and OpenSSH would not catch them, so nobody would notice, and then they would use Go against it, which does the right thing, and that would end up in a bug for us. Like, there's just a whole history of protocol evolution that led us to this moment.
Let's hope we have fixed all the bugs now regarding this mismatch between the K-type and the algorithm type. I hope it's the last one.
We've been waiting to write up the triumphant announcement that you can finally turn off SHA-1 and that SHA-256 is completely supported, and we've had this endless tale of bugs. Speaking of protocol bugs, something I'm very excited about and that I was supposed to do years ago and I haven't done yet is for TLS instead, setting up our tests to run the boring SSL test suite against our implementation. The test suite is called BOGO. And Roland, you were just working on that.
Yeah, it's really interesting. I think, TLS is a really complicated specification, and it's kind of additionally complicated by the fact that while it overspecifies a lot of things, it also underspecifies some things. So there's a lot of corner cases where you kind of get weird interoperability bugs. And boring SSL is kind of the de facto TLS implementation now, basically because it is what Chrome runs. So it has gotten probably, handled more TLS handshakes than arguably any other software. I don't know if someone will probably argue with me about that, but and so that it's kind of the golden implementation for TLS. They have this giant test suite that, was originally just for boring SSL, and it would test, every single protocol behavior that they could think of, and had kind of regression cases for tons of bugs that they had seen. And at some point, David Benjamin, one of the engineers, worked on it to make it to make the test suite applicable to other TLS stacks. So you can, wire up this complicated system to run a Go TLS client or a Go TLS server against a kind of modified version of it. What it turns out is the Go TLS stack, which is written in a way to kind of introduce bugs and cause strange behaviors, so that you can kind of see, is your TLS stack actually doing the right thing? We've had this long-running plan to kind of make integrate this to test the real Go TLS stack, because it's really hard to test. It turns out that there are so many different things in TLS that you could do either correctly or incorrectly. And trying to manually write unit tests for every single possible behavior across, 3 or 4 different versions of TLS, and with, 3 or 4 different types of keys or certificates, or all of this is just, it's impossible for a single person to do. So BOGO is hopefully going to eventually replace a lot of our TLS tests. And instead of kind of writing individual unit tests ourselves, we can then go and contribute tests to the BOGO test suite, which is also, it tests boring SSL, but it is also used for Rust TLS, which is one of the largest Rust TLS stacks. And I think one of the Python ones also uses it. There's a handful of people who are using it. So it lets us kind of not only, test ourselves better, but it also kind of allows for the TLS ecosystem to slowly converge on what is the right answer for some of these things. There is, when I first ran the BOGO test suite, there were a number of real bugs, which we fixed. But the vast majority were, when you encounter an error in TLS, you send what's called an alert, which is like a small, it's a single, I think uint 8 or uint 16 that indicates what it was that went wrong during your TLS handshake. And a lot of in the TLS specifications, a lot of these are underspecified. It's like, oh, you abort the error, you abort the connection, but no one ever says, what alert do you send? So when we ran these tests, we got 100 or 200 errors that say, you're sending the wrong alert when this thing happens. And I went and I talked to David Benjamin, who wrote a lot of these tests. And I said, well, why did you pick this alert? And his response was, it's just what made sense. and I could probably sit down and argue for a good hour or so about why some of the alerts we picked were better than the alerts that he picked. But in reality, it matters. This is not important to anyone. It's probably more important that we do the same thing that boring SSL does than, being semantically correct about which alert you're sending.
In general, I'm a very big fan of this sort of test sharing, because I really think that things that have specifications, which cryptography, a lot of things have specifications, should share test vectors, because there's no good reason what we do is not useful to others. Especially in cryptography, there is no good reason that what we test is not useful to others, and what others are testing is not useful to us. So there are a couple projects like that. One is Weichproof, which is named after the smallest mountain in the US, in the spirit of setting achievable goals, which was a project that was started at Google by Daniel Bleckenbacher and others, and has now moved into a community project that I'm part of called C2SP. And we're going to try to make that into a repository to share test vectors across implementations. And BOGO is, I think, a very good example of that working out.
I'll have to correct you very quickly. It's not America, Australia.
Wait, really?
Yeah.
Mount Weichproof is in Australia?
Yeah, it's in Victoria.
Huh. Oh.
Very important.
I think I've been saying this for a while now. I've been spreading fake news.
I think it's also witchy proof, but
And then we can chalk up to my Italian accent, whatever.
Yeah, if you showed that to an American, that's probably what they would say as well. So
fair enough. But yeah, I placed it completely on the wrong side of the word. Oops. Cool. I'm trying to think what other Go 123 things are there, and I think there's the cryptorand changes, and I can't think of anything else. And cryptorand is the package that you use to get random bytes out of. And it's mostly fine. Like, it's not really one of the things that makes me think, oh no, I wish I could change things in the standard library so much. But it also has a few things we can make a little better. And I'm thinking of doing just a single pass in this release and just clean up all the things. And the first one was actually an idea that came from Russ Cox, which was very entertaining because I was like, hey, Russ, can I make a new API in cryptorand that doesn't return an error and just panics if it gets an error? Because it would be much more usable. And I'll tell you all what the API was. But usually he's the one that argues for being more conservative, right? And so I expected him to be like, well, I don't know, like, how often is that going to panic? And instead he was like, really? Why does cryptorand ever return an error? And like, well, yeah, that's a good point. We're using the system calls on modern Linux, and well, I guess IOS could be a problem. And he basically told me, look, if you can fix it so that it almost never fails, we could just make it throw. And if you've never heard about what a throw is in Go, and you're about to say, wait, Go doesn't have exceptions, there's no throwing in Go. No, there is a function called throw. It's an internal runtime function that just crashes your program, and there's nothing you can do about it. Because that's to make sure that nobody tries to set up recover around it, because there's nothing to recover. And I went in there and I changed how we get random bytes on macOS, because I texted, friends at fruit companies that shall go unnamed. And I asked, okay, so what should we use on your platform? And they're like, yeah, that one is much faster and never returns an error. Would you look at that? And so now we have random bytes that basically never return an error. If you're curious, there's this long proposal that spells it all out. And so we're just going to make a throw and crash the program if you're in a very weird corner case in which you misconfigured your system so much that even with all of that, we can't get random bytes. And that makes me deeply happy. So that's going to be fun. Then I want to make it a little more efficient by not causing it to escape the bytes slice you pass it into the heap so that you can avoid allocations. I want to make it not import mathbig, or at least I want to make an internal version of cryptorand that doesn't import mathbig, so that I can stop some packages that in the standard library that need random bytes and don't need mathbig, which we talked about in the other episode. I can make sure that they don't import it at all. And yeah, a few little changes like that. I feel like there was at least another one. Oh, yes, and there's the new API, which is going to be something you give it charset and can give you a random string made of those characters. So you can generate things like passwords and tokens and stuff like that. And I want to make it an API that you don't configure at all. You just give it the charset, and it gives you back a string using those characters that's long enough to be secure. And then if you know what you're doing, you can slice it down and make it shorter because it doesn't return an error. So you can just put the slice operand right after. And yeah, so fun stuff with cryptorand. Randomness, exactly.
I'm thinking of all the weird password requirements that I've seen on websites. It's like it can only have one digit.
Oh, wow. Yeah, if it can only have one of something. Oh, actually, my position on those is that the answer is that
it's a bad idea. Yeah.
I mean, it's a bad idea, but also you solve it by just generating a password that's just alpha like letters, and at the end you put exclamation point,
and
one, and capital A. And if anybody gives you grief for it, you can tell them Filippo said it's okay. They can.
If you have these rules, this is okay. Yeah, I can get behind that.
Yeah, speaking of how arcane those rules are, I ran across a very fun, I forget where this was, browser game that somebody wrote, where it was the goal of the game was to input a syntactically valid password. And each time you got it right, it would introduce a new, even more arcane rule that you had to follow. It was like, all of the numbers in your password must add up to a prime larger than, something. It got really hard. I don't think I ever finished it. But, I have seen some pretty crazy rules on passwords. So it's good training.
Yeah, there's also that game of prompt hacking that you have to convince it to tell you the password. Yeah.
Oh, God.
I like those games. They're cute. Many things are included in 123. Wow, we covered a lot.
Yeah. Now, when we started this, I was thinking, we don't actually have that much. This is a pretty boring release cycle, but we've managed to fill an hour. So that's a good indication that maybe there's actually more than I thought there was.
I do this every time too. I learned that we actually did a bunch of stuff as I prepare either these episodes or the cryptography State of the Union talks, which, by the way, I just got the email yesterday that it's part of going to be part of the program at GopherCon US. So if you want to hear basically all of this stuff, but again with slides and I don't know, just me being very excited on stage, that's an option.
Filippo wearing a suit.
Yes, also that with a Gopher enamel pin on the lapel.
It's the most important draw.
It's the small Gophers. Also, we're still waiting to hear about Lightning talks, but Nicola, you submitted a Lightning talk, right?
Yes, writing talks to speak about the state of crypto SSH, but I still haven't a replay from GopherCon. I hope it will be accepted, so I can speak also there about crypto SSH and the improvement we are doing in this year, and the new API for the new version that will hopefully include in the standard library. Let's hope. Let's try.
Fingers crossed.
Yeah, there will be also a talk by Zvonimir on the analysis that were done around Go vulnerabilities. Also, lots of security this year. I think it's really good. All the conferences are going to be putting this important focus on things.
That talk in particular will be really interesting. We've been putting a lot of work into vulnerability analysis, and I think, not to toot our own horn, but I think Go currently has probably the most advanced vulnerability analysis tooling out there, and it's still essentially in beta. So I think there will be a lot of value there for developers.
People are often worried about vulnerability, not real vulnerability. For example, I remember some people asking us to update net HTTP in Xcrypto repository, but it was basically unused. So even if that package was vulnerable, that vulnerability is not exploitable in crypto SSH. It was used only marginally in the package. This is very, very hard to explain to people because they run an automatic scanner, and the automatic scanner triggered the vulnerability, and they are alarmed. They want all the vulnerability fixed very quickly. But by doing so, there is the risk that we introduce untested feature because we are always on the bleeding edge, or we always use a new package that people haven't enough time to test and to about regression and so on and such things.
Yeah, this is basically an ad for Govon Check. I think I can do it in like radio style. Do you have issues with a lot of vulnerability reports clogging your pipeline? Do you wish your signal to noise ratio was better? Call Govon Check. That is Govon Check. Anyway,
and coming to the Go toolchain at some unspecified point in the future.
Ask your engineer if beta software is right for you.
But do test the release candidate anyway.
Yes, please.
Yeah, especially if you do strange things. The stranger your code is, the more you should test the release candidate and tell us when you break things.
were you harmed by a release candidate? There might be compensation for you in the form of bug fixes. The compensation might not be available after the date of the release. I gotta stop now.
An interesting thing I discovered recently is, for example, on Debian, there are fixable vulnerability and unfixable vulnerability because Debian developer choose to not backport some vulnerability fix. Initially, was really surprised because vulnerability scanner for my Docker image for my open source project reported vulnerability. But I checked it and I found that all updates were already applied. So I was surprised to see this vulnerability. Then I discovered these things about Debian. So basically, everyone publishing a Docker image or things like this is forced to use something like Distroless, because this way you only ship your Go application with no dependencies, and so you avoid this false positive or this fake vulnerability warning.
If you're anything like me, you have a certain tendency to put things off until the very last minute. Seeing the dentist, going to the doctor, home improvements, that never-ending chore list of yours. And while most of the time it works out just fine, the one thing in life that you really cannot afford to wait on is setting up term coverage life insurance. You've probably seen life insurance commercials on TV and thought, yeah, I'll look into that later. No, later doesn't come. This really isn't something you can wait on. Choose life insurance through Ladder today. Here's what we love about Ladder and why we allow them as a sponsor. They are 100% digital. No doctors, no needles, no paperwork when you apply for $3 million in coverage or less. Just answer a few questions about your health in an application. Ladder's customers rate them 4.8 out of 5 stars on Trustpilot, and they made Forbes' Best Life Insurance 2021 list. You just need a few minutes and a phone or laptop to apply. Ladder's smart algorithm works in real time, so you'll find out if you're instantly approved. No hidden fees. You can cancel anytime. Get a full refund if you change your mind in the first 30 days. Ladder policies are issued by insurers with long, proven histories of paying claims. They're rated A and A+ by AM Best. Finally, since life insurance costs more as you age, right now, now's the time to cross it off your list. So go to ladderlife.com/changelog right now to see if you're instantly approved. That's LADDER life.com/changelog.
I actually think you should probably leave.
So who has an unpopular opinion?
Okay, my unpopular opinion is that you should pay for open source software you rely on. Of course, you can use open source software for free, but maintaining and evolving it's not free. It requires a lot of time and effort, and you should learn to recognize the value of this work. If you use an open source software at your company, then it would make business sense to sponsor that project to ensure it stays healthy and well maintained. You should not think I will use it for free and someone else will pay for me too. Let's look at recent CVE. What do you see? Maybe the XZeta backdoor? Now you understand what can happen if an open source software is not maintained or poorly maintained? Open source maintainers are generally passionate developers who enjoy sharing their work with the community, but if they can't pay their bills, their problem could be passed on to you and your company, and you can lose money, a lot of money. What do you do if you find a critical problem in an open source software you are using? Do you open a GitHub issue? Why don't you start supporting their work instead and establish a channel of mutual access and trust. This way, you will make your business interest because the open source project will be sustainable in the long run. And what will happen? The developer will work on it full time, and therefore you'll get an even better software. This is a win-win, but this is something really easy to understand, but many people and companies miss it. And another thing, maybe my real unpopular opinion, is that often I get as open source maintainer, and I think I'm not alone, email like this: we would like to pay for this feature to be added, depending on the price, obviously. But this is really annoying. You should pay for ongoing maintenance, not to add a nice feature that is only useful to you and maybe only work for your specific use case. And at the same time, you try to negotiate the lowest possible price. And after this feature is added, what happened? Happened that the open source maintainer have to maintain it forever. This is most people and companies are unable to understand this thing. I'm sorry if I was too passionate, but as open source maintainer, this is something that I deal with every day and what I feel inside.
All right, since we're going on open source maintenance, I'll pick one that is not about elliptic curves, and I'll dovetail on that. I agree with Nicola. The other thing that often annoys me, which I think lots of people who are very well-meaning step into it, is when people say, oh, we want to help the project, so we always contribute our patches up. And I can see Roland going like, yes. That's the thing. That does not make the project more sustainable. That sometimes makes the project less sustainable because now the maintainer has to review the patch. And if it's a feature, like Nicola was saying, has to review the feature and maintain the feature forever. Now, it's a good thing about open source. Like, you're contributing to the general open source community and ecosystem. And it's a good thing. And I think we all here are drawn to open source as this collective activity. But it's not helping the project itself. It's not helping the project maintainers because they will still have to review it, will still have to do a bunch of work later on. So it's a good thing, but it does not solve the same problem. And this comes up often because I say, things that sound like what Nicola said, and then people are like, oh, yeah, we agree, we care a lot, we always contribute our patches. And I'm like, which is not to say that you only have to send money. Like, there's a lot of things you can do to help the maintainers. Like, you can go through issues and do the initial triage. You can figure out what is the correct behavior for an issue. You can find out what the spec says. Sometimes I just, look at an issue and decide that I am not looking into that today because it's way too complex. And then I come back a week later and somebody went like, oh yeah, that happens because of this code over here does this thing. And then the spec says that, but actually OpenSSH before that version and after that version, or like, I don't know, OpenSSL does that with TLS, and that's what's happening. And that's great. When that happens, that actually does make the load on me as a maintainer much lighter.
Wow, I feel like we've had two incredibly important and philosophical opinions here, and I'm going to just be incredibly silly now. I have a very basic unpopular opinion, which is I feel like becoming more and more unpopular as time goes on, which is that I think for 90% of time I spend on the computer, I would prefer to use a desktop PC or Mac or whatever than a laptop. I kind of part of what I hate about laptops is that they're portable and that you can take them anywhere and use them at any time. I really like just having my computer in one place and heavy enough that I cannot pick it up and put it in my bag and be forced to do work, down the street when I go to do something else. Less time on the computer perhaps is better.
Then there's the GitHub app.
Yes.
I like it. Put the computer in a box, close the box. The box is a room. We do not go into that room. We do not speak of that room.
There was a period where I was strongly considering buying one of those time-activated safes that I could, put a computer into. But unfortunately, I do still get paged sometimes, so this could be dangerous.
Open that safe only with a code from the pager.
Yeah.
Then it's only when you really have to.
That's a product that you can sell to engineers. A safe with PagerDuty integration.
I would be surprised there's not already something like that.
My unpopular opinion is around pigeons. I recently read a tweet that changed my entire perspective on them. Because for a while, for the longest time, I was looking at pigeons as like, it's not nice to say, but flying rats. But then that tweet was very long and was describing how humans used pigeons for hundreds of years and breeded them exactly to be like our mail carriers until one day we got technology to fix that. And now they're just like depend on us, but we didn't do any proper offboarding, let's say. So actually, it's not their fault. Pigeons are okay.
I'm with you on that one. I'm team pigeon. Yeah. But also, rats are nice. What's the
what's wrong with rats?
When it's a rat pet of yours, that's cool. But if it's a rat that like eats into the foundation of your house or just lives in the inner garden of your building, then it's too much hygiene questions, unfortunately. But yeah, if it's a pet rat, that's cool.
Living in New York, I still remember Mike, the rat that used to live at the 59th Street station. It was actually reassuring. Like I would see him most of the times. I would go to work.
Right. Japan has the loyal dog that stays at the station. New York has the loyal rat.
Yes.
Cool. Okay, that was a very interesting episode. The third one in our series, 6 months after the first one. And I hope the next one will be in like 2-3 months when we can discuss cool stuff again.
I'm sure there will be more.
It never stops.
No.
We must align with the goal release cycle.
Yeah, I think we essentially already have.
Yeah, Roland and I are not admitting to it, but really we're doing this instead of release planning.
You can just say like release notes linked to this episode. You're good.
Yeah, we get into the episode and we talk about stuff and then we look at the notes and that's what we're going to work on.
If you have questions, meet me at GopherCon.
Yeah.
Well, thanks everyone and thank you 3 for joining us.
Thank you.
Thank you.
Thank you.
All right, that's our show. Thanks for hanging with us. Subscribe now if you haven't yet. Head to gotime.fm for all the ways. Or search for GoTime wherever you get your podcasts. You'll find us. If you're a fan of GoTime and get value from the pod, share the show with your friends and colleagues. And if you really dig it, hook us up with a 5-star review. We appreciate it. Thanks once again to our partners at Fly.io, to our Beat Freakin' residents, Breakmaster Cylinder, and to our friends at Sentry. Save $100 off their team plan when you use code CHANGELOG during sign up. That's all for now, but we'll talk to you again next time on Go Time.